Groups of people are complex, in ways that make those groups hard to form and hard to sustain. Much of the shape of traditional institutions is a response to those difficulties. New social tools relieve some of those burdens, allowing for new kinds of group forming, like using simple sharing to anchor the creation of new groups. Imagine you are standing in line with 35 other people, and to pass the time, the guy in front of you proposes a wager. He's willing to bet $50 that no two people in line share a birthday. Would you take that bet? If you're like most people, you wouldn't. With 36 people and 365 possible birthdays, it seems like there would only be about a 1 in 10 chance of a match, leaving you a 90% chance of losing $50. In fact, you should take the bet, since you would have better than an 80% chance of winning $50. This is called the birthday paradox, though it's not really a paradox, just a surprise, and it illustrates some of the complexities involved in groups. Most people get the odds of a birthday match wrong for two reasons. First, in situations involving many people, they think about themselves rather than the group. If the guy in line had asked, "What are the odds that someone in this line shares your birthday?" that would indeed have been about a 1 in 10 chance, a distinctly bad bet. But in a group, other people's relationship to you isn't all that matters. Instead of counting people, you need to count links between people. If you're comparing your birthday with one other person's, then there's only one comparison, which is to say only one chance in 365 of a match. If you're comparing birthdays in a group with two other people, you, Alice, and Bob, say, you might think you have 2 chances in 365, but you'd be wrong. There are 3 comparisons: your birthday with Alice's, yours with Bob's, and Alice's with Bob's. With 4 people, there are 6 such comparisons, half of which don't involve you at all. With 5, there are 10, and so on. By the time you are at 36 people, there are more than 600 pairs of birthdays. Everyone understands that the chance of any 2 people in a group sharing a birthday is low. What they miss is that a count of any 2 people rises much faster than the number of people themselves. This is the engine of the birthday paradox. This rapidly rising number of pairs is true of any collection of things. If you have a bunch of marbles, the number of possible pairs will be set by the same math. The growing complexity gets much more wretched in social settings, however. Marbles don't have opinions, but people do. As a group grows to even modest size, getting universal agreement becomes first difficult, then impossible. This quandary can be illustrated with a simple scenario. You and a friend want to go out to a movie. Before you buy the tickets, you'll have to factor in your various preferences: comedy or romance, early show or late, near work or near home. All of these will have some effect on your mutual decision, but with just 2 of you, getting to some acceptable outcome is fairly easy. Now imagine that you and 3 friends decide to go out to a movie. This is harder because the group's preferences are less likely to overlap neatly. 2 of you love action films, 2 hate them. 1 wants the early show, 3 the late one, and so on. With 2 people, you have only 1 agreement to make. With 4, as birthday paradox math tells us, you need 6 such agreements. Other things being equal, coordinating anything with a group of 4 is 6 times as hard as with 2 people. And the effect gets considerably worse as the group grows even moderately large. By the time you want to go to a movie in a group of 10, waiting for 45 separate agreements is pretty much a lost cause. You could sit around discussing the possible choices all day, with no guarantee you'll get to an agreement at all, much less in time for the movie. Instead, you'll vote or draw straws, or someone will just decide to go to a particular movie and invite everyone else along, without trying to take all possible preferences into account. These difficulties have nothing to do with friendship or movie-going specifically. They are responses to the grim logic of group complexity. This complexity means, in the words of the physicist Philip Anderson, that more is different.